How to identify gold-containing rocks. Tips from a geological engineer. Hello everyone. If you're out in the field or just curious about how to spot rocks that may contain gold, this video is for you. As a geological engineer, I've spent years studying rocks, minerals, and/or deposits, and today, I'm going to share some real, practical tips on how to recognize gold-bearing rocks in nature. Let's break this down into three main parts. What gold-containing rocks look like. Where gold is usually found geologically. What tools and techniques you can use to test rocks in the field. 1. What gold-containing rocks actually look like. Let's start with something very basic, appearance. If you're just walking along a stream or hiking in the mountains, what should you actually be looking for? Gold in its natural form doesn't usually look like what you see in jewelry stores. It can be flaky, grainy, or even form small nuggets, but it's usually mixed in with other minerals. One of the most common rocks that gold is found in is quartz, especially milky white or translucent quartz veins. If you see quartz veins cutting through other rocks, that's a great sign. And if those quartz veins have tiny golden flakes or shiny yellow specks, pay close attention, you might be looking at gold. Now, many people confuse pyrite with gold. Pyrite is often called fool's gold because it has a similar metallic shine. But here's how to tell them apart. Gold is soft. You can dent it with a knife or even your fingernail. Pyrite is hard and brittle. It breaks into sharp edges and gives off a black or greenish streak. Also, gold is heavier, a lot heavier than most other minerals. Another thing to look for is iron staining, rusty, reddish-brown colors on rocks. These are caused by oxidized sulfide minerals, which are often found in the same environments as gold. So, to sum up. Look for white quartz veins. Check for golden flakes or nuggets embedded in quartz. Be cautious not to confuse gold with pyrite. And notice any iron-stained rocks, they can indicate hydrothermal activity, which is often associated with gold. 2. Where gold is found geologically. Now let's talk about location. Even if you know what gold-bearing rocks look like, you still need to be in the right geological setting to have a real chance of finding gold. Gold usually forms in hydrothermal environments. This means hot, mineral-rich fluids move through fractures in the Earth's crust and deposited gold in cracks and fissures over millions of years. Some of the best geological settings for gold include quartz veins in metamorphic rocks, especially schists and greenstones. Contact zones, where two different rock types meet. Shear zones and fault lines, fractures in the earth where hydrothermal fluids can circulate. Placer deposits, these are secondary deposits, where gold eroded from its original rock and settled in riverbeds, often mixed with gravel and black sand. If you're in an old mining area or near fault zones, and you're seeing quartz veins or iron-stained rocks, those are all promising signs. Also, don't overlook alteration zones. These are areas where the host rock has been chemically altered by hydrothermal fluids. You may see rocks that are unusually soft, crumbly, or clay-like. They might be colored white, yellow, or even green due to minerals like kaolinite, cerussite, or chlorite. Knowing some basic geology and reading geological maps can really improve your chances of being in the right area. 3. Tools and techniques to confirm gold in the field. Let's say you found a suspicious-looking rock. What now? You don't need expensive equipment to do some basic field tests. Here are the most useful tools to carry. A rock hammer to break open samples. A hand lens or magnifier to inspect small gold particles. A streak plate to test the color of the mineral's powder. A magnet. Gold is not magnetic, but other minerals like pyrrhotite or magnetite are. A gold pan to test placer material near rivers. And if you want to go a bit further, a portable XRF analyzer can identify gold and other metals on site, though it's more expensive. You can also perform a scratch test. Gold has a hardness of about 2.5 to 3 on the Mohs scale, so it can be scratched with a copper coin or a knife. Pyrite, on the other hand, is much harder and cannot be scratched easily. One more tip: don't just look at the surface of a rock. Break it open and check the fresh surface inside. Weathering can sometimes mask the real contents of a rock. And finally, if you suspect a rock contains gold, the best confirmation comes from lab testing, especially fire assay, which is the most accurate way to determine gold content. Visual and physical clues: what gold-bearing rocks look like. Let's begin with the basics. How do you visually recognize rocks that might contain gold? When you're out in the field, especially in areas with known gold deposits, one of the first things to pay attention to is the color, texture, and structure of the rocks around you. Gold rarely occurs in large, obvious nuggets lying on the surface. That's a romantic idea from movies. In reality, gold is often hidden inside rocks, embedded in veins, or mixed with other minerals. So you need to know what to look for. 1. Gold's appearance in nature. Natural gold has a very distinctive look. It's metallic, with a bright yellow to golden color. It has a buttery or soft glow, not a sparkly or shiny reflection like some other minerals. Gold often appears in flakes, grains, wires, or very small nuggets, and may be spread unevenly throughout a rock. Unlike many minerals, gold is malleable. If you find a yellowish metal and you can flatten it with a knife or a hammer, it's probably gold. If it shatters or crumbles, it's not. 2. Don't be fooled by pyrite, fool's gold. One of the most common mistakes beginners make is confusing gold with pyrite, also known as fool's gold. Pyrite is an iron sulfide mineral and has a metallic luster, but its color is more of a brassy yellow, sometimes even with hints of green or brown. It can sparkle brightly in sunlight, which is why it fools so many people. If you're unsure, try the scratch test. Take a piece of the mineral and scratch it with a copper coin, steel blade, or ceramic streak plate. Gold will leave a yellow streak and can be scratched easily. Pyrite won't scratch easily and leaves a dark, greenish-black streak. 3. Quartz veins, the most common host for gold. Gold is frequently found embedded in quartz veins. These veins are often white, grayish-white, or milky in color and may cut through darker host rocks. If you're walking through an area and you see thick, white quartz veins cutting through bedrock, with possible metallic specks or yellowish grains, or rusty staining along the edges, then you might be very close to a gold-bearing zone. Gold loves to travel with hydrothermal fluids. These fluids fill fractures in rocks and cool down, leaving behind quartz and occasionally gold. 4. Iron staining and oxidized zones. Iron-stained rocks, especially those with a rusty, red, orange, or yellow appearance, are strong surface indicators of sulfide-rich mineralization. These sulfides may have carried gold before being oxidized. So if you're seeing rusty rocks, Gaussian zones, crumbly, iron oxide-rich rocks, and quartz nearby, that's a great place to investigate further. These surface indicators often lead to gold hidden deeper inside the rock or nearby. 5. Other helpful clues in the field. Look for black sands. If you're near a stream or river, and you're panning or observing sediment, heavy black sands, like magnetite and hematite, often accompany gold. Pay attention to the weight of rocks. Gold is dense. Even small pieces mixed into rock can make it feel heavier than normal. Some rocks may contain arsenopyrite, chalcopyrite, or galena. These are minerals that sometimes occur in gold-bearing systems. Summary of what to look for. Bright yellow metallic flakes or grains, especially in quartz. White/milky quartz veins with iron-stained surroundings. Heavy, dense rocks that look out of place. Rusty or oxidized rock zones near faults or fractures. Be cautious of fool's gold, learn to test for it. Knowing these visual and physical clues is the first big step toward identifying gold in the wild. But remember, surface appearances aren't always enough. In the next part of this video, I'll walk you through the geological settings where gold is most commonly found, so you can combine visual clues with real science and dramatically improve your chances of success. Geological settings and rock types where gold is commonly found. Understanding where to look is just as important as knowing what to look for. In this section, we'll dive deep into the geological environments and rock types where gold is most commonly found. If you're a prospector, a student of geology, or simply a gold enthusiast, this is where real knowledge makes the difference between random guessing and strategic exploration. 1. Hydrothermal vein systems, lode gold deposits. One of the most common and productive sources of gold is found in hydrothermal quartz veins, also known as lode gold deposits. Here's how it works. Deep within the earth, hot fluids rich in silica and metals, including gold, circulate through cracks, fractures, and fault zones. As these fluids cool and move upward, they deposit quartz along with trace amounts of gold inside the cracks of host rocks. These deposits typically occur in orogenic belts, zones of mountain building where the Earth's crust has been compressed and fractured. Common host rocks include slate, schist, greenstone belts, granitic intrusions. If you see quartz veins cutting across these rocks, especially in areas with visible iron staining, sulfide minerals, like pyrite, arsenopyrite, or historical mining activity, you may be standing in a prime gold zone. 2. Placer deposits, alluvial gold. Placer gold deposits are what early gold rush prospectors dreamed of, free gold particles concentrated in streambeds, riverbanks, and ancient floodplains. Over time, gold erodes from hard rock lode sources and is carried downstream by water. Because gold is dense, it settles quickly and accumulates in low-energy environments such as inside bends of rivers, beneath waterfalls, in cracks and crevices of bedrock, in ancient stream channels, called paleoplacers. The rocks associated with placer deposits aren't necessarily gold-bearing themselves, but they help trap and concentrate the gold. If you're panning and you find black sands, magnetite or hematite, along with heavy yellowish flakes, you may have struck gold. Fun fact, many of the largest gold nuggets ever found came from placer deposits, but the source rock was often far upstream. 3. Volcanic and epithermal systems. Gold is also found in volcanic-hosted epithermal deposits. These are shallow, low-temperature hydrothermal systems typically located in volcanic regions or near volcanic hot springs. In these environments, gold is carried by hot fluids rising toward the surface. As the fluids cool and react with surface rocks, gold precipitates along with other minerals like quartz, calcite, and sulfides. You'll often find these deposits in andesitic to rhyolitic volcanic rocks, such as tuffs, breccias, lava flows. Look for silicified zones, banded quartz veins, and argillic alteration, clay-like, soft, bleached rocks. These are common signs of epithermal activity. Countries like Indonesia, Peru, and parts of the western U.S. are famous for this type of deposit. 4. Intrusion-related gold systems. These deposits are associated with granite or diorite intrusions, large bodies of molten rock that cooled slowly beneath the Earth's surface. As these intrusions pushed through the crust, they altered and mineralized the surrounding rocks. The gold is typically very fine-grained, accompanied by bismuth, arsenic, or tungsten. Found in sheeted quartz veins, stockworks, or disseminated zones, where gold is spread throughout the rock, not just in veins. Common host rocks include granite, diorite, monzonite, hornfels, a contact metamorphic rock around intrusions. These systems are harder to recognize in the field because gold is not always visible, but geochemical sampling and mapping help geologists locate them. 5. Greenstone belts and Archean terrains. In many parts of the world, greenstone belts, especially those of Archean age, more than 2.5 billion years old, host some of the richest gold deposits ever mined. These belts are made up of Metamorphosed volcanic and sedimentary rocks. Interlayered with basalts, ultramafics, and felsic volcanic units. Often folded and faulted due to ancient tectonic activity. Gold and greenstone belts is often associated with shear zones, deep crustal faults, sericite and chlorite alteration, and sulfide-rich quartz veins. Examples of famous greenstone-hosted gold regions include the Canadian Shield, Western Australia, and South Africa's Witwatersrand Basin. 6. Sedimentary rocks, Carlin-type and conglomerates. In some cases, sedimentary rocks also host gold. Carlin-type deposits, common in Nevada, USA, form in limestone or dolomite. Here, gold is extremely fine-grained, often invisible to the eye, deposited by hydrothermal fluids. Conglomerate-hosted deposits, like the Witwatersrand Basin, are ancient gravel beds where gold was deposited billions of years ago. These require more complex exploration and analysis, visual clues are subtle, and lab analysis is often necessary. Knowing where to search geologically gives you a massive advantage over random exploration. You can now combine this with the visual and physical clues from the previous section to make educated, strategic decisions in the field. In the next part of the video, we'll discuss simple field tests and tools that you can use on-site to determine whether a rock might truly contain gold, including streak tests, density checks, and even how to use acid for confirmation. Field tools and basic techniques for prospectors. So, you've learned about what gold-bearing rocks look like and where they're typically found. But now comes the practical part, how to examine rocks in the field to decide whether they're worth keeping or testing. Whether you're a weekend prospector, a geology student, or a serious treasure hunter, the tools and methods in this section will help you work smarter in the field. Let's break down the essential tools and techniques used by geological engineers and experienced gold prospectors. 1. Rock hammer and chisel, your primary prospecting tools. A good quality rock hammer is a must-have. It allows you to break open rocks to see inside, extract samples from outcrops, reveal mineralized zones hidden under weathered surfaces. Tip: always wear safety goggles when breaking rocks. Fragments can fly off fast and cause injuries. A chisel is useful for prying open smaller cracks or splitting layers in sedimentary rocks. This comes in handy when investigating quartz veins, shear zones, or veinlets where gold might be hiding. 2. Hand lens, 10x or 20x loop, see the details. Gold is often very fine-grained, especially in areas with sulfides or quartz. A hand lens helps you closely inspect tiny mineral grains. Distinguish between gold and pyrite, fool's gold. Look for visible gold, VG, in cracks, along fractures, or embedded in quartz. Gold versus pyrite tip: gold is malleable and has a dull yellow shine under magnification. Pyrite is brittle and shows a more metallic luster with cubic or crystal shapes. 3. Streak plate, test the true color. Use a ceramic streak plate, usually unglazed porcelain, to perform the streak test. This technique reveals the color of a mineral's powdered form. Gold leaves a yellow-gold streak. Pyrite, in contrast, leaves a greenish-black or brown streak. Hematite, often present in gold zones, leaves a red-brown streak. The streak test is quick, cheap, and effective in separating real gold from imposters in the field. 4. Magnet and magnetite test, check for black sands. Gold is not magnetic, but many minerals associated with it, like magnetite and pyrrhotite, are. A small hand magnet helps detect the presence of magnetite in black sands. Indicate nearby mineralization typical of placer deposits. Narrow down your panning or sampling zones. If your sample contains heavy black sands that stick to a magnet, you might be close to gold-bearing material. 5. Gold pan, the classic tool of prospectors. The gold pan is simple but powerful. It's used for washing away lighter materials, silt, sand, leaving behind heavier minerals like gold, garnet, magnetite, and hematite. Use the pan to test soil, streambed sediment, or crushed rock from outcrops. If you see shiny, yellow flakes that settle quickly to the bottom. Don't float. Don't break apart when rubbed. You may have gold. Pro tip: always pan near bedrock or natural riffles, like roots, boulders, or crevices. That's where gold settles. 6. Hardness Test Kit, Mohs Scale Identification. Using a simple Mohs hardness kit, or even your knife or fingernail, you can test a mineral's resistance to scratching. Gold has a hardness of 2.53, so it's softer than a copper coin, which is 3. It can be dented or scratched with a knife blade. Pyrite, on the other hand, is harder, around 6 to 6.5, and will resist scratching. 7. Acid Bottle, Spot Gold and Carbonates. Carrying a small squeeze bottle of dilute hydrochloric acid, HCl, or muriatic acid helps identify carbonates. Like calcite, they fizz or bubble on contact. Sulfide minerals, which may react depending on their composition. Fake gold, chalcopyrite, pyrite, which can tarnish or break down. Gold, on the other hand, is chemically inert, it won't react to acid. That's a good way to confirm a suspicious sample. 8. Geological compass and GPS, know where you are. Field prospecting is not just about what you find, but where you find it. Always carry a compass with a clinometer and a GPS device or phone to record the exact location of samples. Measure orientation of veins or faults, strike and dip. Mark promising areas for return visits or detailed mapping. This information becomes invaluable if you plan to analyze patterns or report potential findings. 9. Field notebook and sample bags, document everything. Even experienced geologists take notes, and so should you. Document rock type, color, texture, and mineralization. Weathering patterns. Any visible structures, veins, faults, fractures. Date and GPS coordinates. Use sample bags or containers, preferably labeled, to collect specimens for later testing. If you forget where you found a promising sample, you lose its value for further study. 10. Portable XRF Analyzer, Advanced Prospectors Only. For serious prospectors or geological engineers with access to equipment, a handheld X-ray fluorescence, XRF, analyzer can provide real-time geochemical analysis in the field. It detects trace elements associated with gold, arsenic, silver, antimony, bismuth. It helps identify anomalies or subtle mineralization before laboratory testing. While expensive, XRF technology is becoming more common in exploration campaigns. Final advice: combine tools, trust observations. The best prospectors don't rely on just one clue, they combine visual indicators, basic field tests, geological knowledge, and practical tools. A golden rock doesn't always glitter, but it leaves signs if you know how to read them. Don't forget to practice responsible prospecting. Respect private land and permits. Avoid excessive disturbance to natural sites. And always follow safety procedures.